Photoelectric equation. The photoelectric effect is observed in a metal when light of frequency above the cutoff frequency for the metal is shone on the surface of the metal. The energy of a photon of incident light, E, must be greater than the work function, W0, of the metal in order for the effect to be observed. According to the principle of conservation of energy, the total energy in any interaction cannot change. It is conserved. A part of the energy, E, of the photon is consumed in removing the electron from the metal, that is, the work function W0, while the remaining energy is converted into the kinetic energy of the electron, kinetic energy max. Therefore, E equals W0 plus kinetic energy max, where E is the energy of a photon of light, given by E equals hf. W0 is the work function of the metal, given by W0 equals hf0. Kinetic energy max is the kinetic energy of an electron ejected from the metal surface. Consider two electrons, one on the metal surface and the second electron below the surface. The electron at the surface will have the maximum kinetic energy when ejected. The electron deeper down will have lower kinetic energy because additional energy is required to eject the electron, since it is attracted by a greater number of positive nuclei in the metallic lattice. Kinetic energy max represents the energy of the electron that is on the metal surface. The electrons ejected from the metal will all have different energies depending on where they are in the metal. According to Einstein's theory, there is an upper limit to the energy of a photoelectron emitted by a particular frequency of light. The above equation is known as the photoelectric equation. The maximum velocity of an electron can be calculated by using the equation kinetic energy max equals half m Vmax square. Let us apply the photoelectric equation. Light shines onto the cathode of a photocell. The microammeter registers a reading. Each photon of light has an energy of 7,9 times 10 to the power negative 19 joule. The cathode is made of a metal whose work function is 6,66 times 10 to the power negative 19 joule. Calculate the maximum kinetic energy of an ejected photoelectron, the maximum velocity of an ejected photoelectron. Solution. From the photoelectric equation, E equals W0 plus kinetic energy max. We are given the work function of the metal. We are also given the energy of each photon of light that is used. The energy of each photon of light is greater than the work function of the metal, so the photoelectric effect will be observed. Substituting the values. Therefore, kinetic energy max equals 1,24 times 10 to the power negative 19 joule. We can find the velocity of a photoelectron using kinetic energy max equals half m Vmax square, where m is the mass of the electron. Vmax is the maximum velocity of the electron. Substituting the values. Vmax equals 521,755 meters per second.
Starting to feel it? Now go master it with Maski.